Welcome back to the channel. In today's video, I'm going to discuss PCA again because I received a question on one of the videos asking, what is PCA doing? Is there a different way that I can show this? And so as a man of the people, I felt obliged to make another video on this technique, as this is a great technique for measurement scientists and data scientists in general. And so I really want to make sure that you understand what it's doing, at least in principle. And so here I've written most of the code to produce a data frame, do some data visualization, and perform PCA so that we can look at what it's doing. If you understand this, pause the video. It's all there. And so I will begin by producing this heat map, looking at just the analytical data as a correlation matrix. And so the points that are more white or beige are showing areas where we have high correlation between a pair of variables. In this case, you see clay is highly correlated to itself, so it's white. But then there are cases where we see this anti-correlation. And this is really what I want to focus on in this video, is looking at these patterns in the data from the context of correlations. And so when we look at this overall heat map, we see that many of the variables are somewhat correlated or strongly correlated with each other, with the exception of this EXP variable. In this case, we can see that across the board, EXP is in this dark purple color. And according to this color bar, this would indicate that it is at least weakly correlated or anti-correlated, which is different than all of the other variables here that tend to be more orange, red, or beige. And so this is essentially what PCA is doing, is looking for these patterns that it can then use to summarize the underlying data structure. In this case, I would see this data and expect EXP to break out probably in PC1, if not PC1, definitely PC2, because most of the data is moving up and EXP is moving down based on this correlation matrix. And so to help visualize this, let's look at this side by side. Let's create a new view for the notebook and look at two different sections. And so now let's look at the loadings plot for PC1 as a bar plot. So on the left side, I have my heat map, and on the right side, I'm focusing on this bar plot. If you can see that when we look at the loadings plot for PC1, many of the variables are in the positive direction. That is, they tend to move in the same direction, with the exception of this EXP variable that is in the negative direction. And that is the type of pattern that PCA is looking for, is that it can now summarize PC1 as a variable that has most of the variables moving in the positive direction and one variable moving in the opposite direction. And that is what we can see here. However, there's another pattern that I observe when I look at the heat map based on the correlation of these analytes, and that is with pH. You see that when we look across the board, pH is largely positive with the exception of its relationship to the OM, or organic matter variable. And so this might be a case where we have another area where we have some similarity based on this correlation. And so let's look at PC2. Here we can see that as many of these variables are moving in the positive direction, there are a couple that have a negative movement. So pH is a strong one, and we see that here it is down, but definitely clear for pH. And again, these are the types of patterns that the PCA model is trying to pull out to summarize the overall movement in the data, or patterns within the data. I hope this helps. In any case, like, comment, subscribe, and I'll see you in the next one. Peace.
Subscribe to the channel.